Hi guys, we are continue with our neat coding and the next task of binary search. So let's take a look how it will go. All right, so I'm going to neat code and go to roadmap and binary search. So the next task is Coco eating bananas. Interesting. So let's get started. Open LeetCode. Yeah, reload default to default thing, and yeah, so let's get started. So what does it mean? So we have some Coco who love eat bananas, and there is n piles of bananas. The eat pile has some number of bananas. The guard have gone and will come back in some h hours. Coco can decide her bananas per hour eating speed of k. Each hour, she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. So Coco likes to eat slowly, but still want to finish eat all the bananas before the guard return. So we have to return the minimum speed such that she can eat all the bananas with 8 hours. So we can see that we have 4 piles, and we see that guard has gone for 8 hours. If we will choose the speed, yeah, so let's go with some examples. So we have 4 piles and with numbers of bananas. And we have some guards who went for 8 hours. So what can we do? We can choose, for example, some speed that we can eat all these bananas within 8 hours. So if we will choose 3, for example, so for 3, we'll spend such amount. So 1 hour here, 2 hours here, 3 hours here, and 4 hours here. So in total, it would be 10 hours. So it's more that we need. So if we will choose 6 hours, then it's still 1 hour. Here it would be 1 hour. Now it would be 2 hours and again 2 hours. So in this case, we see that it will be 6 hours. So we see that for 6 it would be more than 8, and for 3 it would be greater than 8. So we need something in between 3 and 6. Something in between 3 and 6. So actually, what can we do at the beginning? So as a first algorithm, we find the pile with the best speed, or with the speed greater than h, right? When we found this pile, we take previous or 1 and find by binary search the appropriate speed. So here we go by n. It will be even not n because, for example, we need to go n, and then for each of this one we should calculate. So it will be n squared, and here again like n squared. So in total, if we will take a look, this algorithm take time with n squared. And space, we actually don't need additional space, so it would be constant. Okay, actually what we can do better is to find the try to find this speed we see that piles is also not sorted. Yeah, so what we can do is find the minimum and the maximum, and then go by binary search and check if we have speed that will cover all the cases. So for example, 3 and 6, we can like find 5, and we can calculate, okay, 5, it would be 1 hour, then 2 hours, 2 hours, 3 hours, and in total it will take like 5 plus 3, 8 hours. 8 hours is okay for us, but we still want, if we take 4, for example, it will be 1, 2, 2, and 3. Yeah, so it also would be 8. So we can see that 4 and 5 actually are the same. So we always should take kind of, yeah, so we always should take kind of the smallest value. Okay. So idea is the following. So find min, max, and then binary search and calculate. So binary search would be log n plus n, and we also will do this log n time. So it's something like this. And so log n, so it's not n squared, but n log n. So in total, this will take n log n time. Which is better? Which is better? Okay, so let's try to implement this logic. All right, so find min and max. So I have min piles 0, and also I have max pile 0. So I'm going by each pile, and here min would be mass min of min and pile, and here max would be max and pile. All right, so and here now I'm so what I want to do, so while max minus min is greater than 1, and here I return min. Okay, so min I always just move when I have, so I have also need to have a private function sum that's returning integer, and here I have like piles and speed. So how it would look like, this sum is actually result. I'm going by pile, item piles, and I have my speed. So for example, if I have speed of 4 and current pile is 3, so I like 3 divided by 4, it would be 0, right? And yeah, I can calculate like if item is less than speed or equal to speed, then result 1, else I should calculate. So I do the following. I divide item by speed plus I should check if item by speed greater than 0, then 1, otherwise 0. Result. So for example, if I have 11, I divide 11 and speed 4. So I divide 11 by 4, and 11 divided by 4, it would be 2, and plus 1 because I have reminder. Then I return results. Okay, so I have my sum, and now I do my binary search. So my mid would be max minus min divided by 2 plus min. Okay, and here I just calculate this sum. Yeah, calculate sum with piles and mid. And I check if sum is equal to, if sum is less or equal to h, then I move max to mid. Otherwise, I moved min to mid. Right? So let's run. Three, 4. Expected 30, but I have 4. Here also 4. Yeah. So let's calculate. So here it will be 3 and 11. And yeah, so 11 minus 3 is greater than 1. So I calculate mid. How I calculate mid? 11 minus 3. It would be 8 divided by 2, 4, plus 3. It would be 7. And then I calculate the sum. So for 7, I actually have 1, 1, 1, and 2. So my sum for 7 should be equal 1, 1, 1, and 2, so it would be 5. Yes. So I should update my mean actually to 7. So let's print what I have here. Neat plus sum. Let's check. Okay, so I'm not printing it. Why? Why I'm not printing it? Max. Okay, run. Okay, so now I'm print. So I have mid 7 and sum 5. Yeah, so that's correct. And I update my age. If age is greater, yeah, then I should move here mean. Here it would be max. Yeah, run. Okay. So now I have 7, and mid between 7 and 11 would be 11 minus 7. Yeah, it should be 9. And for 9, we see the same 5, right? So 5. Yeah, we still see like 5. So I have 7. If I will take less than 7, so for example 6, it will still have the same. Okay. Okay. But here I need to get 8, right? Output 4. It should be 4. because returns the minimum speed. Okay. And if I will take max, here min. Yeah, so if speed is less than h, yeah, then this sum, if it's less. So for example, I take 7 and I see that, yeah, it eaten less. So then I should move my maximum to 7. Yeah, that's correct. And after this, I move my, and if I will return maximum, okay, so it works with maximum, and let's submit. Yeah, so we have here a problem. I believe that it can be with maximum integers. So expected to output. Yeah, I believe that it can be with maximum integers. $69 result item okay, it's one. Okay, and if I will show minimum, yeah, it's still the same. Yeah, I think here is actually I go with, yeah, so I have speed this one, right? And I calculate the sum. So I should move maximum all the time here. But we don't have print, so I think that I'm not going here. So maximum, yeah, so yeah. So here we see that these two values are actually the same. So these two values are actually the same. And in this case, I think in this case, if piles length is greater than 1, then I could do something like this. Yeah, when I calculate it. Else, I can just update my min with, I don't know, 1. Let's try. Okay, and let's submit. Okay, we have another test case. Okay, so we are decreasing 105. Maybe I think that I'm just thinking like maybe I just need just to find the maximum, and minimum would be always 1. So here minimum would be like 1, and I just need to find maximum and just calculate. And in this case I have like piles and the speed. Output 2, expected 1. Okay. And if I will take 0, and then in this case I think it would work. And let's run. Okay. Yeah, this one I believe it's about out of boundary, because we have quite a big amount of values, and so here see like 1, 3, and maximum would be 1. Yeah, so this sum, when I calculate this sum, it's become negative. So I can just check like if sum is less than 0, I can just return maximum. Let's check. Or I can, for example, calculate, I believe, with longs. I can calculate with longs, I believe. Yeah, so I see like this. Yeah, so we see that we solve this question, but I think that maybe we don't even need this. So maybe we can just take integer maximum, integer max value. Can we do like this? Yeah, we still can do it without this 4. With this summing, so yeah, so we calculate like the medium, and summing up. I'm thinking whether we can increase productivity of this summon. Maybe we can do it more like better. So here it can be long, and then long, and maybe I don't need this thing. Yeah, I can see right here. Yeah, I can see right here. And then submit. Oh, we see that runtime with longs actually decreased much. So using long, it's something that worth to actually check. Because with integers, we see that it slightly bit better. What if I will check some other things? All right. Yeah, we see this for block, but I think it's not needed. The same here. So they calculate it. So we have mid. Hours spent 0. Then they go through each pile. And yeah, so the same, like they have this iteration actually inside of this pile. So maybe I just, maybe I'm just do it very complicated with this if blocks. I think that, I think that this maybe comparison is quite a complex one. Maybe we can increase our performance by other way. Like, actually, do I need this comparison? Maybe I just can calculate it in this way, and that's it. The submit. Yeah, so we can do it even better. And this sum. Yeah, and this printing also decrease our performance as well. Well, let's submit. Yeah, so we see that actually our logic should work with 81%. All right, so we solve this cocoa eating banana task. So actually it's not so complex one. So we have some values that she eats. Actually, as we see, it doesn't really much matter here. It can decrease the number of like searches by some value. So for example, yeah, so if I will try to find a pile like this, I don't think that it's, that it will improve our performance much. So let's check. I don't think. I think it would be still like 82%. Yeah, so the same. Because it's logarithmic time and we are doing binary search. So yeah, so we have our binary search here. We are finding our median value. We're summing them. Here we have for not overflowing this check. And yeah, we still need to calculate for each speed our number of bananas that she will eat. So that's it. Thank you and see you next time.